the charge is present only on the surface. I'll give you 5 minutes time. Analyze it. So it's like a cylindrical pipe. The charge is present only on the cylindrical, like a plastic pipe. The charge is present on the surface. It's a long. It's a long, not a short that one. It's a long that one. A long non-conducting cylindrical shell. That one. Long in the sense infinity. Maximum books, they avoided this particular systems. Only just 1 or 2 questions are there. That's why we may feel they are not important, but can be asked in advance. Already rotating charge ring, one question I discussed in dipole moment. So anything you can pick up. Now, see, this is, we took for ring, no? Now it is a cylinder, like this, different charged systems, non-conducting charge system will rotate. I'll bring some magnetic field, so they'll explain say torque. So many concepts can be related, no? So rather than dipole moment something, we are more bothered about only the field generated. Yeah. Then this sigma. The charge is present only in that blue color shaded one. Please notice that. On only charge on one, non-conducting, no charge will be there only on one surface. Don't make any guess. Try to show that mathematically. Don't make any guess. Huh? Try to work out like. With Ampere circuit law only you have to work out. Don't go for Biot law. Nowhere it is helpful. No. Biot law, you have to say goodbye to this. So what I do is like, I'll assume a system like this. This axis about which it is rotating. So let me assume a strip. In this particular strip, I'm further take like this. So let this be the strip now. And one more strip you assume. So when they're rotating, what happens? That strip, the charge present there will be moving, and as if like some current carrying sheet, and it's a long, no, actually it's an infinity. So like that, shall we just say that there's a one sheet here where the current is out of the plane, and what about here? There's a one sheet where current is into the plane. There's like a two, like a current carrying sheets are present. Able to get this? So it is as good as like a current, like a moving current carrying sheet, no? So actually there's a charge, actually it's rotating. So here what happened, the positive charge is there. Positive charge out of the plane. Positive charge out of the plane means So it's as good as like on this edge and here positive charge into the plane. So this is equivalent to what you can. So I'll nearby, I'll just show like this. So the same green color strips nearby what you can put. This is equivalent to current coming out of the plane. Here equivalent to current out of the plane or into the plane. That one only. So charge, because omega, look at how the velocity here will be in this direction. So now let this be equal to the width of this, let it be ds, and let this be equal to dl. Now how this sheet will produce field here. So bring out those two sheets. Only a part of strip here. Actually, it's a long no, so I'm just for our convenient, I'm just showing only this one. So this is strip like this. You bring it. Now, how B bar due to this should be? So there's a green color. Okay, we'll take this one. Yeah. B bar due to this will be here in this direction, here like this. Yeah. So what about B bar due to this one will be in this direction and in this direction. What about magnitude? Magnitude is same. We have to calculate the net field. We'll take superposition. We'll calculate field inside and outside the pipe. Okay, now you know. Once you get that, like a similar to current carrying strip, I think you can manage. And what about here? We are seeing this. DSI to represent, no? The velocity into the plane here. I'll show like this. This will be out of the plane. Velocity vector will be like this. Velocity vector will be in this direction. So this should be the, okay, I don't know. Please try to, let me keep like this. So I'll separately bring another sheet. So there's a sheet. Anything you take, current. This is DL. This is S. This is V, no? So what is V? V should be ds by dt. Tangential velocity should be equal to ds by dt at this particular point. Tangential velocity. So what will be the tangential velocity? And this is what ds you can take it. So what is V should be equal to? V should be equal to ds by dt. This I'll try to avoid. Now get into the problem now. Apply Ampere's path. So this will be a curved path. Like this. What should be the length of the path? You can take it equal to dl or anything, that one, almost equal to this length. Or I'll try to avoid this. A lot of things. And directly look at this diagram and check it. So what is dl? This length is dl. Straight away, only one strip. At least you do one thing. At least do for one strip here. BDL here only. If you want to come from here, this is the. And how B bar will be in this direction. Here B bar will be in this direction. So looking at this diagram, what you can write? Looking at this diagram. If you are looking at this, either one, look at only any one, either this strip or this strip. So write expression for B. So 2BDL. So I'll let me take this one. 2BDL equal to mu naught into DI. How much of current in that? Let it be DI. So what is DI? Should be equal to total charge enclosed here let it be dq. So 2b dl equal to mu naught dq by dt. What should be the dq? dl into ds, sigma into dl into ds. So this should be 2b dl mu naught dt sigma dl into ds by dt. Now, what we can write it, I'll bring it further here. V is what? ds by dt or dl by dt I should write. V as, this V is ds by dt, no? Or look at here. At many places I indicated. So this V should be equal to ds by dt. So 2b dl is equal to mu naught sigma dl ds by dt. Just put like this. Huh? So substitute, no? So 2b dl equal to mu naught sigma dl into v. dl get cancels. So 2b equal to mu naught sigma. Again the same thing, no? What we earlier we had. What is v? We don't know v, no? What is v? We have assumed it. What is v? v is equal to r omega. So for rotating cylinder also, we are able to bring like this. So this is the magnetic field due to one strip. Okay, let's come for now inside and outside. There's a point P, P1. I'm interested in these things. P2 and P3. At P1, P1 is here. Huh? P1, this is P2, this is P3. Okay, in all the diagrams you can indicate, no? What should be the resultant field at point P1? There's a tangential velocity. ds is what? Arc length. V is the tangential velocity. V equal ds by dt. You can do by long solenoid. but I want you to think. So you try with a long solenoid one. Current per unit width you have to define that. You'll get the same answer. Because again, if I rotate with angular acceleration, no, due to long solenoid, you find little bit difficult. That's why I just brought a very generalized method. Now let's come for this one. There's all the background. Now let's come for this. Okay, now what is the field at point P1 inside the cylinder? Shall I say will add up due to this edge, the field produced by this edge and this edge will add up. Now you have to ask question, sir. Remaining here also, I can assume a strip, they'll also produce. This is like an equivalent method. Sir, I'll assume strip here, I'll assume strip here, I'll assume strip here, I'll assume strip here.
Sir, how did you get 2B, sir? When we were deriving the same thing for
Ampere,
solenoid,
ampere, ampere. Wait. Listen for me. Ampere circuit law. BDL, BDL. Here will be perpendicular. Oh no.
you told outside the solenoid there will be very less number of lines of force, so we are taking B outside to be 0.
I'm not saying this is solenoid. I'm not saying solenoid. No. Then why you are generalizing things?
It will practically be like a solenoid only. No, sir.
Listen for me. In the end, you can clarify your doubt. Okay. Then now let's come for field at point P1. Field at point P1. Shall I add up these two B's? Super, because there's a one sheet. There's a one sheet. No. B plus B. This will be mu naught sigma r omega by 2 field at point P2. I should take superposition. Field at P2 due to blue color one, B bar is there. Due to this red color one will be there, no? I told you whenever two sheets are there, you should take superposition here. Not only this alone will be there, even in the absence of this, there'll be B bar here due to this sheet. Then in the absence of this, there'll be B bar due to this sheet. When both are present, the resultant field. Okay, no, I think now you are in better position. I'll put it. I think problem over now. So what is the field strength at point P2? Will be 0. All asking questions, please do notice now. How it has become 0 is very important. How it has become 0 is very important. So therefore, for rotating cylinder, charged cylindrical shell, where the field will be confined. Field will be there only inside the pipe, and how it will be directed? It will be directed in the direction of omega. Is it okay? Check the ones. The direction of B bar inside the cylindrical pipe will be directed along the axis of cylinder. Look at the resultant B bar. Resultant B bar will be in this direction. What about field here? Will be 0. I'm not saying like a directly that one. This will produce field. This surface also will produce field. The resultant due to that will be 0 here. This is what you have to assume like this. So this is like a solenoid only, but don't call solenoid. Solenoid is totally different. This is like a analogy you can compare for solenoid. Yes. Field inside the solenoid will be non-zero, no? Field outside the solenoid will be 0. This is external to solenoid. This point P2, P3 are external to solenoid. P1 is inside the solenoid. Got it one? So these are the some things are there. After this, how much of energy density per unit or energy density? What is the formula for energy density? Energy density is given by UD. So this is equal to, similar to that, B square by 2 mu naught. Magnetic energy density. Where all field is present, there a magnetic field energy is said to be present, and that we define it as magnetic field energy density, and multiply with the volume, you'll get the total magnetic field energy. So they may test you what is the field magnetic energy density inside the rotating cylindrical pipe, non-charged pipe. See, this is a method. Why we are not considering other strips? Why you're not considering that like that? What when you are going to add 2B, 3B, 4B? This I just took some elemental strip, so you can consider this to be like a ring better and work out. Since you are aware of the sheet, no, I just made problem very simple. Or else what you should assume, it's like a ring of radius 2 pi, radius r and the width dl. Then work out the problem. You'll get the same thing. Since you are very familiar with the square sheet, no, so therefore I introduce like this. So I like a, we can also take this like a strip. So some this like a ring of radius 2 pi r and the width dl. It's rotating, and you know due to rotating field, what is the magnetic field? Work out, and there's the elemental ring. It become elemental ring. You can use try that also. If you want to try, you'll get the answer. Okay, fine. So this I'm generalized way I'm putting this one. Just it's a like a one of the method I'm showing that one. So if you want, you can try that one. So what to try? It is like this. This is a ring. Instead of this strip, no, so you directly take a ring like this. DL radius of this is what the radius of that one only. So let the charge in this be dq. rotating ring, you know what is a magnetic field. Like that you add up. You'll get same answer, nothing. The method is different, no? The approach is different here. There's a elemental ring. What is dq? Dq, you should write it as sigma into 2 pi r into dl. Are you getting now? The things will be little bit, you have to be careful here. Then work out the problem. First you calculate the b bar due to this ring, then due to total. Okay, now two coaxial dielectric cylindrical shells. Already we know formula, no? It's a directly substitution of formula, nothing big is there. Two coaxial. There's another method. Try it, you'll get the same answer. Okay, let me put the diagram in a little bit simplified way. There is a two rings are there. Already you know formula. Take help of the only the resultant superposition of the fields. You carry on and get the answer. The radii are R1, R2. These shells begin to rotate in same sense with angular velocity omega 1 and omega 2. I think the angular velocities are different. So for this, we'll show omega 1, omega 2. Charge densities sigma 1, any sense. Okay, I'll do one thing. I'll take clockwise. Earlier I took this one. I'll change the sense of rotation. Now get into the problem. So here you just don't go for all that mathematics directly. You know formula. Here current will be out of the plane. Current due to this will be into the plane. Or else you can assume a ring concept and bring it. It's left to you, either one. So here also it will be out of the plane. Here it will be into the plane. And nearby that show the B bar. So show B bar. So how B bar. So I'll call this will be B1, no? B2. This is B2. This is B1. This is B1. This will be B1. What we should do? So there are points are there for us. Colors I do. Resultant field we have to show it now. I'll show all the fields. Huh? Just give me, because only that particular structure will not produce. It will produce everywhere. So this is the B2, B2, and this B2 should also be present here. No? some name I don't know what symbols to give. And I'll do one thing. Structures 1, 2, 3 already we used, no? A, this will do one thing. A, B, C, D. It will produce field BD, BD. Superposition of all the fields, like a 4 current carrying sheets are there. In that way, what you're supposed to assume here. Okay, fine. This is again similarly now due to this, due to C, it will be here. Okay, no. So now due to A and B will show it. Due to A, it will be BA, BA. Due to B, it will be now directly we know magnitudes, no? The field produced by C and D should be equal. The magnitude should be equal. BC equal to BD is equal to how much? Mu naught sigma R omega by 2. Mu 1, no? So it is mu naught sigma 1, sigma 2. Yeah. Now similarly, the field produced by A and B, mu naught sigma 1 R1 omega 1 by 2. Then take superposition all, you'll get the required answer. Now, what about the field at distance R from the common axis? For R less than capital R1, R less than R12. So first we'll go for R less than R1. What about the resultant field? Shall I say all will get added up? I try to see the arrows. Due to all sheets, it should be added up. BA plus BB plus BC plus BD. So this should be mu naught. Total it will be sigma 1 R1 omega plus mu naught omega 2. Now for R, C and D will add it up, whereas due to BB and BA will get cancelled up. Only due to C and D it will be there. You check it now. BA minus BB will come. BC plus BD. So only due to mu naught sigma 2 R2 omega 2. Now for R greater than R2. Shall I say 0? Getting the idea? So the superposition. So or else you do one thing, you take the ring method. In the ring method, what will happen is for you calculating field inside, okay, outside will happen again, little bit careful. That's why I just took this method. Whatever the field due to ring method, due to elemental ring here, no, whatever the field outside, you find little bit difficult in a numericals like this. So that approach is only for that particular cylindrical shell rotating. What is the field inside? Okay, fine. Therefore, there's a very generalized method what books they proposed treating like this. So it'll be much easier, no? What about the field density, energy density? We can take out in different structures, like at different points, field inside, we can manage, you know. Okay, now we'll go for last one. The okay, next class we'll discuss. No, find the magnetic pressure on the wall of the pipe. Magnetic pressure.